Hello students, today we will learn about the dyes and the principles behind dyeing and also the terminology that is used in dyeing and also the printing, and we will also see how we can select the dyes based on the end use and also the differences between the dyeing and printing. The visual sensation of color through the human eye is possible due to the reflection of light from any surface. As per the physics theory, when all the light rays are reflected from any surface, it appears white, and when all the rays of light are absorbed, it appears black. We are able to see one color because that particular surface is able to absorb all the colors except the color that is sensed by the human eye. And thus, when we take a red color, for example, when we are able to see a red color, that means that that particular object will absorb all the colors except the red. That is why we are able to see the color. Particular color is a universally accepted and it appeals to everybody, and so consumers, when they go for the selection of the fabrics, and the first thing that they see is the color. When the color appeals to them, they do not bother much about the other things, and so color is an important aspect on a textiles. The art of dyeing is thought to have originated in India or China earlier than 2500 BC. Dyes capable of giving full range of hues on linen are known by 1400 BC. Dyed fabrics remained a luxury for a long time, for around few centuries. Natural dyes with their limited shades dominated as a colorant on textile fabrics. The discovery of modern tinting, that means that it is treating the fabrics with metal oxides before immersion in the dye baths, really have increased the shades and also the color fastness of these fabrics, and thus it started giving more and more number of shades. But these dyes varied in their quality, in their color fastness, and also the variation was seen so much in fabric batch wise. These conditions changed dramatically in 1856 when an English chemist, William Henry Perkin, accidentally discovered the first synthetic dye, mauve, while attempting to make quinine from coal tar. Thereafter, synthetic dyes totally replace the whole textile field by having lot of brilliant shades on different types of fibers and fabrics. Color can be added to textiles by using dyes or pigments. Pigments are the insoluble color particles that are held on the surface of the fiber or the fabric with a binding agent. A dye is an organic compound responsible for giving color to the fabrics. To define, a dye is a compound that can be fixed on a surface in a more or less permanent way, and that evokes the visual sensation of a specific color. Dye molecules are colored because they are able to absorb or reflect certain light rays, so that visual sensation of that specific color on the surface is being produced. Principles of dyeing and selection of dyes. Dyes are natural or synthetic substances that add color to the fibers, yarns or fabrics. Dyes may combine with fibers or fiber molecules, attach themselves to the fiber surface, or be absorbed into the fiber without the chemical action. Coming to the composition of a dye molecule is a conjugated system or having a conjugated framework wherein it is having the double and single covalent bonds that alternate between the atoms, and this forms the framework for each dye molecule. Within the structure, there are specific groups called chromophores and oxochromes. These are very important for the dye as they make organic molecules become colored. Thus, we can get the dye molecules that are useful for dyeing the textiles. In general, chromophores give the dye molecule its specific color, while oxochromes intensify the color in the dye molecule and also make it water soluble. Coming to the chromophores, this name is derived from the Greek word chrome, means it is color, and phore means it is from pherin of the Greek word, that means that it to bear. See, these chromophores are unsaturated organic radicals. Their specific state of unsaturation enables them to absorb and reflect incident electromagnetic radiation within the very narrow band of visible light. Chromophores are made up of some organic molecular arrangements such as the azo group, anthraquinoid group, nitroso group, nitro group, and carbonyl groups, and so on. To produce color visible to the human eye, the dye stuff must have at least 2 chromophore groups in each molecule. A molecule possessing no chromophores cannot give the color, and so it becomes colorless. Then coming to oxochromes, the intensity or the brilliance of the color depends upon the substances that are called oxochromes. The name is again derived from Greek, that is oxin, that means to increase, and chroma means the color. Again, these oxochromes are also organic radicals which include carboxyl groups, sulfonic groups, amino groups, methyl amino groups, and hydraulic groups, and so on. So, a dye molecule without oxochromes would lack intensity of the color, and this is because the incident light waves would not be absorbed or reflected in a uniform way, and also the sensation of these colors will not be so good as we see in a dye molecule with oxochromes, and so oxochromes are compulsory in a dye molecule. And these oxochromes tend to be polar, and this increases the overall polarity of the dye molecule, and thus this increases the water absorption of the dye molecule in water. As a result of the physical interaction between the chromophores and oxochromes, the dye stuffs that are used on textiles are having very high intensity, so that they are able to give lighter to very dark shades, unlike the other materials. Other substances, other colored substances do not have that much intensity as you find in the dyes. And then coming to the selection of dyes, how are we going to select the dyes for textiles? Textiles can be dyed in different ways. They can be dyed, that means the whole fabric or the fiber or the yarn can be dyed in a water bath, or it can get the dye in the form of a print or a design which is imprinted on the fabric. So, we have to actually select the proper dye so that it is going to be fast on that, and so generally we have to consider the quality of the fiber, yarn, or the weave in the fabric. So, this also play an important role, and this may change the color of the fabric. And also we have to even consider the finishing process through which the fabric has gone through, and then the suitability of the dye to various end uses. All the dyes cannot be expected to have the fastness to all conditions such as washing, perspiration, crocking, or sunlight, but they must be fast to the conditions with which they will come in contact with or get exposure to the particular end use. The selection of dyes of a particular class depends upon various considerations such as cost of dyeing, availability of the required shades in that particular class, and fastness of the dyed materials, and the brightness of the shades, and ease of dyeing. So, these are the considerations we have to consider, and while selecting dyeing or printing any fabrics. Dyes usually diffuse into the interior of the fiber from a water solution, and they are retained in the amorphous areas within the fibers. The oxochromes assist in the even uptake of the dyes, and because they make the dye more soluble in water. It is the oxochromes that enable forces of attraction to form between the dye molecule and the fiber polymer, thus improving the color fastness of the dyed and printed textiles. Dyes are generally retained within the fiber by hydrogen bonding or covalent bonding or ionic bonding or mechanical entrapment. Few dyes react with the fiber polymers to form covalent bonds. Dyeing is a chemical process involving the principles of migration, diffusion and retention. First, the dye must migrate from the dye bath onto the fiber surface and be absorbed on the surface of the fiber first. Then the dye must diffuse from the fiber surface and into the center of the fiber. Finally, fixation of the dye within the fiber is possible with a covalent or hydrogen bonding or other forces of attraction between the dye molecule and the fiber polymer. So, this is the principle behind the coloration of the fabrics and the fastness of the dyes on the fabrics. Terminology related to dyes and dyeing. Oxochrome. This oxochrome intensifies the hue of the dye molecules and makes the dye molecule soluble in water. Barry. It is a horizontal shaded band running across the width of the fabric. Bleeding is color loss through washing in water. Color flare or metamerism. This is a condition when two or more types of fabrics are dyed, particularly by different dyers. The colors may appear to match in one light, that means it may be a daylight, but will not match in another light, that is incandescent lights. Then chromophore is the color producing portion of the dye molecule. Color fastness is the term used to indicate the durability of color on fabric to various conditions such as washing, crocking, sunlight or perspiration, etc. Crocking is color loss from the colored materials by rubbing. Dye is the molecules of the organic compounds called dyes. These are responsible for the color of the dyed and printed textile materials. Dye process is the environment created for the introduction of a dye into the fabric by either hot water or steam or dry heat. And dye lot numbers. Once a color has been selected, it is essential that its formulation be kept consistent, and so each batch that is dyed must have its own dye lot number, so that there will not be any ambiguity or any kind of problems that comes later. And fluorescent dye, that means that it glows under ultraviolet rays and it absorbs light at one wavelength and then it remits that energy at another wavelength. These dyes are used in safety clothing to increase the visibility. Then migration, that is shifting of color to the surrounding area or to an adjacent surface. Offshade refers to the color that does not exactly match the standard or prepared samples. Pigments are insoluble color particles that are held on the surface of a fabric with a binding agent. Their application is very simple, quick and economical. Printing is the localized application of color on the surface of the fabric in the form of a design. Shade bar is a horizontal band of different color or light or dark shade of the same color running across the fabric. Shading is a variation in color tone either horizontally or vertically, generally caused due to the uneven twist that has been given to the fabric or uneven tension that is being given during the weaving process. Stained fabrics indicates a discoloration caused by a foreign substance, a dirt, grease or oil or any sizing residue on the fabric before dyeing. So, it makes a shaded fabric. Differences between dyeing and printing. Textiles are generally colored by using two methods of imparting color, that is dyeing and printing. In dyeing process, the fiber, yarn or fabric is impregnated with a dye by immersing it in a dye bath, wherein the color is obtained wholly on the textile material. In printing, a pattern or a design is imprinted on the fabric in one or more colors by using dyes in paste form or some related means. Examining the outline of the design is required to know whether the color or has been obtained on the fabric through dyeing or printing. The outline or edges of a colored portion of the printed design is so defined and it's so sharp, so that we will be able to see that we can even differentiate that it is a printed one. But when you take a dyed material, even though there is a kind of color in localized form, and that the outlines are very hazy and it will not show defined outline. And sometimes even in printed materials, dye will be or the color will be obtained on the wrong side. Generally, the color will not come onto the wrong side that much. So, we will be able to see the right side of it, and also they will be able to differentiate that it is a printed fabric. But sometimes when a sheer fabric is present, the color comes onto the wrong side also in so well that it is sometimes difficult to see difference between these. And then when we see especially the self edge and all, then we will find whether it is a dyed one or not, because sometimes the color may not be there. But if it is not so, if it also get the color, same color, then it is better to ravel the yarn and see. Definitely raveled yarns will have some portions which are not colored, by then we will be able to identify that it has been produced by printing. So, sometimes there are counterfeit textiles that are available by just printing a design which is otherwise very difficult to produce or very costly to produce by dyeing method, is simulated through printing, and these fabrics are sold as that kind of fabrics. Like example, we can give that ikat fabrics. Ikat fabrics are dyed, and then the process is such a complicated one, and the same thing can be even printed, but by seeing the edges we will be able to identify these things. And so, differentiating between these two products, dyed and printed textiles, are important, because the color fastness definitely varies, and the consumer should know whether the fabric, while selecting whether the fabric is being dyed or printed, so that he can buy it economically in case of printed materials. While selecting the dyes, we have to also consider whether there is substantivity of the particular dye on the fabric. For example, the dyes that are used on cellulosic fibers may not be good on the protein fibers, and in the same way the dyes that are being used for these natural fibers may not be used on the synthetic fibers, because they may not be able to color those particular fabrics. Because in case of natural dyes, they have very good absorbency, and so generally the color gets inside the fabric. And so dyes like direct dyes or vat dyes or naphthol dyes, and such dyes can easily color some of these cellulosic fibers. And in case of protein fibers, again, due to the difference in the fiber polymer, and usually basic dyes or acid dyes can be used on these fabrics. And when we take the synthetic dyes, in fact, first when synthetic dyes were discovered, and there was a lot of problems in dyeing these materials, because particularly these fabrics could not be dyed with the dye stuffs that were available at that time. And so, they have gone again for in search of some of these dyes which can really dye these synthetic fabrics, which are hydrophobic in nature. They do not absorb the dye so well, and so we required a kind of pressurized and high temperature dyeing using dispersed dyes and things of kinds of those dyes that can give the color on these materials. And so, the selection of the dye should be based on the substantivity of that particular dye on the fabric. And then we also see the end use, that is very, very important. For example, when we take a apparel material, then we are going to wash the fabric, wash the garment several times and also dry it. And so, generally it should be fast to washing, sunlight, and also crocking and perspiration. Perspiration is human, it depends upon the individual, and so it should be fast to that conditions. But if you take drapery, something like a curtain and all, then it requires definitely fastness to sunlight rather than the washing, because you do not wash them very often. So, like that, depending upon the end use of the fabric and the fastness is required. And so, while selecting the colors, we have to even see the characteristics of the dyes, that the fastness of the dyes, and so whether it will be useful to this condition or not, will be able to make a decision.